Noah's Ark. How would Ron Wyatt's, or either a box to barge or triangular-like shape, have performed in a global flood? By Ronald Stewart, 2017, all rights reserved. Part number 2. In part number 1, we studied this Deruniper anomaly that is a boat-to-canoe-like impression that was thought to be Noah's Ark by the late Ron Wyatt. However, we noticed that in a video on one of the Ron Wyatt's websites, what we saw was Wyatt's Ark developed differently. Now here at this URL, which is on that, is the Anchorstone International site, as we see here, where the first URL also has a video. Now the video is here, as we see here on the bottom, and it's entitled Tests Show Droguestone's Effectiveness on Noah's Ark, or rather, the late Ron Wyatt's Ark. Now, what is interesting to note is that in the Ark, whether here he did a test on the shape of the boat to canoe shape like Ark. The top is white, the yellow part is the bottom of the boat. But what he didn't show you is when the wave comes, we slow down the film, there's the large wave, and right there what they did is they left it open as though it would have had open air vents, just like we see here in a box-to-barge like object also shown in the black lines. That could have been similar to Ron Wyatt's Ark here, being tested for stability and also in the water. So what would have happened with a box-like Ark as well? The water would have inundated it and it would have sunk, as we see here. But now we're going to take a look at this from that the wave action is so intense that now here if it had air vents, it would take on the water and capsize and completely go under. However, the question was asked, could possibly drogue or even maybe anchor stones attached to the Wyatt Ark would have been able to stabilize it and keep it on course, as we see here? What we learned from this experience was, however, what we continue to learn in Ron Stewart's rendition of Ron Wyatt's Ark with drogue anchor stones on it to stabilize it in the global deluge, that these anchor stones with air vents on top would have only, the water would have washed in the holes or the air vents, and basically what it would have meant is just like we saw in the water test, it would have sunk. The water would have gone into the air vents and it would have inundated it, filled full of water, and everyone would have perished inside. And if this was the case, you and I would not be here today. So there had to be a... However, what is important to learn about now is how would a box-to-barge like shaped ark have performed in a global deluge? We now look at more information on this as follows. But here, so what we see here now is a graph, a scientific graph on top from Hurricane Katrina from 2005 in August, where wave surges got up to at least 67 feet in height, or sometimes even 75 feet in height, about every 3 to 4 minutes or less. and sometimes every minute to minute and a half. And this was just for a period of 1.5 days. And yet where the arrows point right there is where the water would splash up and go into the air vents as seen on the arc on the bottom. Right there where some of the pointers are pointing to right now. And so we're going to zoom in on that and show that a little closer. And here we have more scientific data to verify what would happen. Hurricane force winds for 40 days and 40 nights and in a flood, and yet Katrina only lasted about a day and a half or 2 days, the worst part of it, and a global flood for 40 days, 40 nights would have lasted 25 times longer. So here's a scientific data sheet from the U.S. National Scientific Buoy Test Center from Hurricane Katrina 2005 that shows wave surges got up to 67 plus feet. And as close as true conditions as we can come to understand what a global deluge may have been like. The other images depict how such waves would have engulfed the ark in this shape and design. It's shown at the right top. Water would have come in, shown right here where the arrows are pointing to. And what would have happened, as we see it there along the catwalk, then the water would have gotten inside, it would have filled up. And the plain and simple truth is that the laws of physics say that water will seek the lowest source, therefore the empirical laws follow as well. Now, here is A depicts water, it's about 45-50 feet high, crashing up on a rock, horizontal rock, that would be about the same size and length of a boxer barge like Noah's Ark. But yet B simulates the ark in the same conditions with the same type of waves splashing up on it, and it is high enough to where it would splash into the air vents or openings. I'm going to take a look at further is a close-up view of the end of the ark on how it may have been subjected also according to the waves in the water on the left end if it was a box-to-barge like design. We zoom in on that to get a closer view of it to see if the water would have gone inside the vents. And here, upon closer examination, we see that the water would have washed in the vents. Now, here's a comparison on worldwideflood.com of a triangular-like arc on the left. On the right is a box, according to a Korean study in 1992. Now, here on the left is the original information in the first ark study done at Scripps Marine Laboratory between the 1970s and the 1980s. It shows here the ark would be subjected at waves of 55 feet high or so, and it would have turned, almost capsized, at a 90-degree angle. But yet the study that was done by the Korean box barge study in 1992 shows that the ark would have been more stable. And yet, the information that we see here is not commensurate and consistent with each other. The study done at Scripps Marine Laboratory in the 1970s and 1980s may have possibly in some ways been more accurate than the study by the Korean box barge study from 1992. Now, the point is that here, let's say this red arrow simulates a person. Now, right there, that horizontal line is a flower in the possible arc. If it tilted at a 90-degree angle, the person would have tumbled from one side of the box-to-barge-like arc all the way over to the other side in just one surge of one wave, which very well could have killed them or even at least injured them very severely. Yet there were waves sometimes maybe as often as every minute to 3 minutes. And yet for a period of 40 long days, So the point is that it would seem like that this study from the 1970s is more commensurate here to what we saw in the test on the Juniper-like arc, in which it was turned to 90 degree area as well, in which here we saw it flip over. Now here on arc design number 2 in worldwideflawed.com, the bottom area shows here an arc test that was done possibly in the early 2000s, late 1990s to 2000s, but when you press it, it doesn't show the video. Now, is there a possible reason here? Now, these take credit that the sail in the back of this box test that was in the water would be similar to a sail that would need to be made on the box-to-barge-like arc, as we see in the Creation Museum arc exhibit that is in Kentucky. However, is there a reason that maybe they don't show this video? It very well could be. The reason why this video may not be shown is because it would reveal something that maybe allegedly does not want to be revealed. In other words, the Ark encounter at Answers in Genesis theme park is based upon a sail in the back that would help supposedly keep the Ark design stable. And the video shows some things that may not want to be known. Now, does this mean it was done on purpose? No, it does not mean that. It simply means that this video shows some things that where they thought, allegedly, that this design would work, but when we slow the video down and we look at it very carefully, we find out what this video reveals. Now here, we're going to try to tap the here button and show you that when you do this, this is all it does. It shows no video at all. And the link is broken and has been broken for a while. Now, we're going to zoom in on this because this is a video we're going to show in a little while, and it was made sometimes between 2008 and 2009. And yet the Ark Encounter theme park is pretty well built on the worldwide.com design. But here we look at this part and it says why the new look. The first part of the text reads as follows: while there could be other solutions to the design of Noah's Ark that would still comply with the biblical specifications, here we, the designers of this design that's used in the Ark Encounter, attempt to combine modern knowledge of how a ship behaves in the water with some of the surprising technology of ancient shipwrights. Continuing to talk about this particular video, it says, is the rigid sail really necessary? And why the underwater projection? It almost looks like the bulbous bow of a modern tanker. Or is it related to the rimming bow of a Greek terrene? Here we're still trying to get the video to play and it won't play. It continues to read, these features work together to control the Ark, using the wind, Genesis 8:1, to maintain direction and avoid broaching. See video demonstration. Well, we keep trying, but it doesn't play at all. Now, we're going to watch this video that would not start to the right. because I do have that, and additional information with that as well. But first, what we're going to consider is this design that will be inside this video and show how it has striking similarities to the Ark Encounter design in Kentucky, the theme park, today. More of this now is to be seen as follows. There is an artist rendition of the Ark Encounter before it was finished and how it would possibly look. Now, if we look in the upper left top corner, we can certainly see a cell-like projection. But we're going to take a look at this compared to the image inside the video. Now here we analyze the situation further. On the left is the artist rendition from Ark Encounter theme park. The blue line is representing the water level. Beneath it, the gray area is under the water. Now, when we look at the sail, right there on where the yellow arrow is pointing to right now, that raised area is a sail to help try to give the impression or that this design would have used this sail to be able to go through the flood. However, when we look at also the right side, this is the actual Ark test model. It has a sail in the back as well. Yet we see the water splashing up on top of it. Did the Ark model test pass? Here, we're now going to take a look at the 2008-2009 Noah's Ark box-to-barge light water test, but yet, in truth, it sinks. Now, we may remember earlier at worldwideflood.com, they showed this video, and we attempted to even start it as we are doing now, and yet every time we did, it's doing what we see here. Now, let's take a look at the video itself. Now, we have slowed it down, and we're going to show images of basically what the entire test was about. Here is that video, and then here's the images, which is about 28 seconds or so long, maybe a little longer. Now here we see the test model in the water splashing up in the cell in the back. It's in the water. Right there we see the water splashing up, and if it was vents right there, it would get inside the open air vents inside the model. Right there we see the cell in the back where this was tested. Now we get even closer and show the cell again, and there we also see the water splashing up on the Ark model. Yet now, what are we going to do? We're going to show this even further and show additional images, that still shots, that is, part of the frame of the video. And what we're going to take a look at is this water not only splashing up, but actually what happens. Now here we see it starts to go under the water right there, and barely sail is sticking above the water. It is taking on water and it is beginning to sink. It's not just going down into the water and popping back up, because now it is completely sunk underneath the water, and this was the result of that 2008 to 2009 box-to-barge like model test. It sunk. Period. It sunk. Period. The 2013 box-to-barge like Noah's Ark model water test with open air vents. This was done in 2013 by and in the ocean in Corpus Christi, Texas. Now as follows. I, Ronald Stewart, performed a test on another model. As we see here, here's the waves. Now the model was about 2 feet long, and the catwalk was made shorter so that it could try to stay afloat longer to give it the benefit of the doubt. However, the waves here would have equaled waves 60 to 75 feet high. And what we're going to do is take a look at this, and we're studying the wave action in slow detail, which we just saw the arc there on top. Right there is the catwalk where the little hand is moving around right there, and right there's the end. Now we're going to show that catwalk in red, right there where the red arrow points to. Now here's an enlargement of an extreme close-up. And of course it's got air vents in it that were about half, maybe about 1/4 inch high and maybe 3/4 of an inch long or less. And what we're going to show is that here, where the red arrow points to, we see the waves actually going above the top of the catwalk. So if this was a real arc, it would equal about wave 70 feet high. The red area was where the catwalk was. Now here, we can see it completely inundated and filled full of water. There is another position of showing the part of the arc. Right there, the side view. Right there where the little arrow points to, and the catwalk above it. But now, what we're going to do here is we're going to show one of the air vents, and we're going to give an extreme close-up of the 2000 Noah's Ark box test model, zooming in at and showing what the seawater and how the foam is entering the vent opening in the catwalk area itself. Now as we zoom in on that, the arrow points to the small little opening that we're going to zoom in extremely close to. And then what we're going to do is attain higher and higher resolution images of the hole itself, or the vent opening that would be in the catwalk. And we're going to show right here within the red square area what that looks like. As we then zoom into it again and we clear up some of the blurriness, we're going to zoom in a second time and take a look at this catwalk in this hole. But right there between the two yellow lines is an angled roof above the catwalk. Now we're going to take a look at the vent on the left, which, as you can see right there where the red outline is on the left, is one vent hole. And now if we look at the one on the right that we're going to get ready to zoom into and attain higher and higher resolution images, it is about equally spaced, equally apart, showing that these would be vent holes. So the one on the right, though, is the one we're getting ready to zoom into, and we'll show that with a yellow arrow again where that is at. And as we zoom into that, then we'll take that area, that dark area, and then we'll attain higher and higher resolution images to show what it looks like. And that's how we're going to take care of that. Now, here, as we zoom into it, and we still see it on the right, here we now see the area and attaining higher and higher resolution images to be able to go inside and see if seawater and foam are entering this vent area here as well. Now we continue to attain the higher and higher resolution images, and getting closer and closer to that right now. Area with the water And as we increase the focus, we get more clarity with higher and higher resolution images. And we're going to explain this further in just a moment. Now, it's shown first in black and white. There's the foam area where the little hand is pointing to, right there, and that area right there is the vent itself, which is maybe about 3/4 of an inch or an inch long, maybe 3/8 of an inch high. My point is that in black and white acts as a visual aid to see it in one perspective, and here it's in its original natural color. Now it will be annotated. An open air vent, extreme close-up. We see the water and the foam going inside the vent area on this 2013 Noah's Ark test model. Right there is the vent opening, an approximate shape of it in the water that we have seen before in this test. Right there. And that is what we are trying to take a look at. As we continue to study this more, what we see is the white area is the foam from the seawater. The seawater and foam are entering the vent, opening in the catwalk, where the red pointers point to right now. Where the upper pointers point to, that is the opening, the air vent opening in the catwalk, which is just directly above it. That would be on like a box to barge, like shape and design for Noah's Ark. Now we're going to zoom into it to get even a closer view of the foam and seawater entering into the vent, as we can see here. What needs to be further understood and clarified is that when other types of Noah's Ark box-to-barge-like shape model tests were done in the past, in the 70s and 80s, and also in the Korean study as well, possibly, that they did not have open air vents. I mean, it's like taking a piece of wood and throwing it in the water. Of course it's not going to sink. It's going to float because it has no way for water to get in. So this is the true way to do a Noah's Ark box-to-barge-like test as far as water and as far as stability and being able to float on top of the water in like manner as well. But we see water entering here. Next, we also did a simulation, computer simulation, and show on the left that when the pontoon-like areas are added to a triangular-like shaped ark with the apex cut off on top as one of the features, that is much more stable than just a triangular shaped like ark, and even more stable than the box ark, much more. Noah's Ark, is it a box or triangular or triangular A-framed house-like roof shape instead? We're now going to give that more study and also see a test. Now, how the triangular-like design could still be consistent with Scripture in the measurements, 300 cubits long, 30 cubits high, and 50 cubits wide, as seen here. Above is the way it may have appeared back in 2400-2350 BCE when first built and after it landed as well. As we continue to study now the triangular-like shape and design, here we're going to explain by the different arrows how it would have functioned in the global flood. The first arrow in the upper top left corner shows it as the water would splash on either side of the ark 40, 50, 60, 70 or more feet high. It would simply just wash over to the other side as indicated by the second yellow arrow pointing in the middle bottom of the image here as well. And that is the benefit of this type of design of this roof. Next, where the two red arrows point on the bottom, that is the pontoon that ran up the length of either side of the ark and would help keep it lifted up above the water line, and also added to the strength of it going down into the water when bothered by the waves. Now the second arrow shows and points to the two smaller yellow arrows that show the pontoon-like area from one end of the ark to the other, 300 cubics, or about maybe 512 feet long, approximately, based on the 20.67 inch cubic, or maybe a little larger. The next arrow points to the double aqua-colored arrow, points where the pontoon on the left side, for example, would be, and here the larger aqua-colored arrow points to the one on the right, and where it is showing where that is as well. Now, what about the air vents? The air vents ran on both the left and right side of the ark and had way of draining the water or diverting the water. There would be one on the left, according to the information we have seen and studied from possible remains of the ark. There on the left would be one opening that would run up and down the length of the ark, and then fresh air would come in here, for example, and it would blow out the other side, or vice versa, and that's how it kept a moderate temperature, also got out carbon dioxide gas that the animals and humans would breathe out, and plus methane gas from waste, body waste, etc. And it would come out the other side. And that's how they were able to survive inside the ark for approximately 40 days and nights, and also longer, until the ark was opened and the vent and the covering was taken off, according to Genesis 8:13. The air vent goes from there to there, as the red arrows have just indicated. When we continue to study the ark, earlier we aforementioned that a study, computerized study, was done on the triangular shaped ark. Now to the extreme left we see the triangular-like shape, but has the long spontoons, or either like pontoons, that went up and down the left and right side of the ark, as we have just seen in the image before. And this pushed down in the water as it moved up and down, but also caused thrust forces to push upward in two locations along each pontoon-like appendage as inertia pressed down from the top. Now, we demonstrate this more in the next image, which is larger for us to see, as of course the blue area represents water, and the gray area are the appendages that on the left and bottom side of the A-frame part of the ark that are under the water. The red line underneath this right end of the ark represents the bottom of the ark, as the appendages were lower than the bottom of the ark, as we see here, and stuck down into the water. As the red arrow indicates, as the ark moved up and down, the inertia pressed downward. Now, the thrust forces from both of the pontoon A-frame-like areas on the left and right side would push upward, as we see there in the yellow arrow on the left and the right, as it would push upward and keep the bottom flatter part of the ark up near the top of the water, as the two pontoon-like appendages were extended further down into the water. And this helped give an easier ride, greater stability, and greater strength to the ark as it survived in the global deluge. In a triangular-like shape. Now we're going to watch a video on its design. It's pushed down here, as you can see in this video, which we're also, this is a 2006 triangular arc model arc test, being tested for stability and seaworthiness, and open air vents by Mr. Nick Romer, here available at this URL. We continue to investigate and examine this further. We're going to zoom in here to the area where we're going to choose one of the open air vents, and we're going to take an extreme close look up at it to show that these air vents are open, and then we're going to study it some more. Now here we've zoomed in on near the front, and we're going to show approximately the location of the different air vents with the red pointers right there where it says in annotated text air vents. And we're going to choose not that one but the second indicator on the far left, and we're going to zoom into that one here in just a few moments. But we want to show that when this is pushed underwater, right there in that little yellow rectangular area is the air vent that we're going to choose to look inside and go from there. Now, as we continue to study that further, we're going to zoom in even closer as the yellow arrow points to the specific and particular air vent that we're going to get an extreme close-up view of, and going to see what it looks like. And we'll study it so we understand that all these air vents are open, and when pushed down and underwater, it's taking on water as well. Now here's a projection of that air vent. Of course, we're going to show a much higher resolution image of the air vent and show you what it looks like, and then study it further. Now here is an extreme close-up, but here's a much higher resolution image there. Now we're going to outline it in the, show where the little hand is right there. Those areas are solid. We can see that's a cavity right there. And it's possibly about an inch long, maybe 3/8, quarter of an inch high, somewhere around there. And now we're going to outline the higher resolution image of the open air vent, and the arrows show that right there it has depth, and of course that's the bottom part of the air vent, and where it goes into the catwalk that we see right there behind it, behind the outline, that is. Now we've seen that extreme close-up of the air vent, so we know that they're open. All right. Now, next, here we're going to give as much study, but we're going to slow it down. And what we want to show here is that, of course, there's the line of air vents right there, as we showed earlier. And Mr. Romer here is going to push down with all his strength and weight on it, and it's going to be completely submerged underwater a couple of times. Now see there, now he's moved, he's shifting his weight. Now we'll zoom in on that. Now we see here him grab hold of the other side, and he pushes down right there. He's beginning to push it down, and that now the air vents here, we see water coming in the back end where his left hand is. Now we see it pushing. Now we see foam right there showing bubbles right there where the arrow just pointed. It's taking on water quite a bit up and down. And now here he's pushed the whole triangular-like shaped arc underwater. We can see water rushing in. Now it's still underwater here, and the back end is still underwater, but the front part has popped up. Now the back part has popped up as well. Probably the exertion of the thrust forces against his hand. Now we see the triangular shape right there, like that. and with like an apex with a top cut off, like a pyramid with a top cut off. Now he brings it back with his right hand. He's going to flip it over to show the stability of it. It flips over quickly, faster than what we saw the previous test of the Juniper arc, and a box-like arc as well. Here he's going to push down, again flip it over, and he flips back very quickly, as in the original 23-second film, but here we've slowed it down to show it flipping over. Now here, there it flips over again. There, stopped it, it flipped back again. Over and over again, right there. In conclusion, we end taking a look at the way, and one of the hypotheses as to how the ark may have been built, available here at this URL. Here we see the framework of the possible ark. Next, the different floors, the first, second, and third floor as well, in a triangular-like shape. Here's what the front may have possibly or could have looked like. And here is another view in the length of it in like manner, in this model, which is also available at the previous URL, AGS Consulting. Next, we're going to take a look at what the flood may have looked like in animation, as we see it here, and as also at this following URL, as follows.